Many of the differences we have already seen about the platform dependency and the system programming, application programming, design goal, the go-to statement, which is not supported by Java, multiple inheritance, which is not supported by Java, but can be achieved with the interfaces, the operator overloading, it is also not supported by the Java. The pointers are not supported by Java. There are two things, that compiler and interpreter, where you can just compile many of the programs in Java. The compiler and interpreter we can use. Also, the call by value and call by reference, it is supported by Java. The structure and union does not supported by Java, and Java has built-in support. C does not have thread support. The documentation is also not supported by C++, but supported by Java. Let us hope that next thing that we have to turn about the Java virtual machines. Let us hope that Java virtual machine is a very important part in the Java architecture. We have to see about the Java virtual machine. It is also called as JVM. What is this JVM? The Java virtual machine is a particularly that type of engine which provides the runtime environment that to drive the Java code or application. So it is Java bytecode into machine language. So particularly, whatever the Java we can source code we can write, that is converted to bytecode, and again it will convert it to the machine language. JVM is particularly a part of Java runtime environment, that is called as a JRE, Java runtime environment. Whenever we are starting to run any Java program, JRE will help us in running of any program, executing of any program. In other programming languages, the compiler produces machine code for a particular system. So, but in Java, the compiler produces code for Java virtual machine. It is known as Java virtual machine. So what is that? So particularly you see the last sentence, the Java compiler produces code for virtual machine known as Java virtual machine. So that is a Java virtual machine. What is that? Java virtual machine which will provide the runtime environment to drive the Java code or application. Very important. So how to run any Java code, Java source code? So with the help of Java virtual machine. So it will convert the bytecode into machine level language. So this is important thing about the Java virtual machine. But how its architecture is working? Next, in our next slide, you are watching about the Java virtual machine, how it works. So here the JVM, that is Java virtual machine, how it works, you can see here. Firstly, Java code is compiled into bytecode. So first thing is done, that Java code is compiled into bytecode. So this bytecode gets interpreted on different machines. And again, between the host system and Java source, bytecode is an intermediary language. So I see that in our C Sharp also, there is something about the intermediary language like MSIL. Like this, in Java also they are using intermediary language. So that is particularly source code is compiled into bytecode, and that bytecode gets interpreted on different machines. Mute your mic. Pallavi, mute your mic. JVM, Java Virtual Machine, is responsible for allocating memory space. So Java Virtual Machine is responsible for allocating memory space. So any Java program will require any memory space, that will be memory space which is allocated by the computer. So all these Java source code will be compiled and interpreted. Here is one figure which shows that the particularly Java code takes from the class loader, and then it will convert it to bytecode verifier, and the last process is it will be get executed by execution engine, that is a Java virtual machine. So this will be a working of Java virtual machines. All these things here you can say what is the particularly architecture of Java virtual machine. So this is a Java virtual machine language classes. There are many language classes of Java, and those are actually from the class loader. See here, that is a JVM memory, that is Java virtual machine memory. There are number of parts, that is method area, the heap, the Java virtual machine stack is also there. The PC registers are also there. The native method stacks are there. So these all are the Java virtual machine memory. Later on, the Java virtual machine classes will be sent to the execution engine, and the whole particularly source code will be transferred and translated to the native method interface, and native method interfaces, after that native method libraries will be get supported to that particular source code. So that is the Java virtual machine architecture. So let us see about the every point, that is class loader, method area, heap, JVM language stacks, PC registers, native method stacks, execution engine, native method interface, as well as the method libraries. Let us hope we'll see next. Pallavi, mute your. Okay. Next, that is the first thing. Pallavi, mute your mic. Otherwise, I will just remove you. Okay. The first thing, the first in our figure, the class loader was there. What is that class loader? The class loader is a subsystem used for loading class files. It performs three major functions. For example, loading, linking, and initialization. So this is the functioning of class loader. So what is that? It is a class loader subsystem used for loading class files. It performs three major functions: loading, linking, and initialization. So class loader will containing subsystem used for loading the classes. So many classes are in the Java. So those classes will be loaded by class loader. Next is a method area. So what is that? JVM, Java Virtual Machine method area, stores class structure like metadata, the constant runtime pool, and the code for methods. So this is the method area. What is that? This method area which will stores class structures like metadata. Metadata is some sort of some sort of a files where we can store the related information of our source code and what is that program, what it does, how many classes are there, how many functions are there. So these all will be stored in the metadata file. So the constant runtime pool and the code for method that will be stored by method area. So everything is stored in the method area. The next is a heap. So heap, what is that? Hello, Ankita, stop your, mute your mic, Ankita. All the objects, their related instance variables and arrays are stored in the heap. This memory is common and shared across the multiple threads. So what is that heap? One of the component of Java virtual machine is a heap. So all the objects which are used by Java program that will be related to instance variables, and the arrays are stored in the heap. So we know that we are using the number of variables, objects, the arrays, all these will be stored in the heap. This memory is common and shared across the multiple threads. So this is a particularly heap memory is a common memory which can be shared across the multiple threads. Now thread is a different part where we can see later on about the threads. Next is the Java virtual machine language stacks. What is that? Java language stacks store local variables and its partial results. Each thread has its own Java virtual machine stack created by simultaneously as the thread is created. A new frame is created whenever a method is invoked, and it is deleted when method invocation process is complete. So what is that Java language stack is there? Java language stack stores local variables. All the local variables will be stored in the stack, and its partial results also. So this thread has its own JVM stack. Every thread is also has own JVM stack which will be created simultaneously. So when you are writing source code, when you are executing source code, simultaneously the thread is created, the method area heap is created, and the new frame is also created whenever the method is invoked. If method we are going to invoke, the new method is invoked, and it is deleted when method invocation process is complete. So these are the parts of our figure which was shown just earlier to this slide. Next, that is the PC registers. So you can see the PC register. PC register stores the address of the Java virtual machine instruction which is currently executing in Java. In Java, each thread has its separate PC register. See, PC register stores the address of the Java virtual machine instructions. Every instruction will get stored in the PC register, and each thread has its separate PC register. So if you are using many threads, every has own PC register. So native method stacks which hold the instruction of the native code depends on the native library. Now when we start to write our source code in the Java, our code will be get translated into native code. So in this, the native method stack is also used to hold these instructions of native code which will depends on the native library. So it is written in another language instead of Java. Sometimes this is developed in C++. So sometimes you can use the C built-in functions, also C functions we can use in the native method. The next is the execution engine. What is that? It is the software used to test hardware, software, or complete systems. This test execution engine never carries any information about the tested products. Now see here, this is the type of software which can be used to test the hardware, software, as well as all the complete system. So that is the execution engine of our Java. It will never carries any information about the tested product. If any product which is tested, that will never carries this information. Now next is a native method interface. The next part of Java virtual machine is a native method interface. The native method interface is a programming framework which allows the Java code running in a JVM, Java virtual machines, to call the libraries and native applications. So Java native method interface is a particularly programming framework. So this is a programming framework which can be allowed the running of JVM to call all the libraries, all the functions, and all the native applications. Whatever the native applications you are running with the support of Java, that will be the native method interface. So those will be again running on the JVM. The next is a native method libraries. So native method libraries is a collection of the native libraries like C and C++. So libraries may contain many of the functions which are written in C and C++. So you can see here, there is a very important role of C and C++ in Java, because many of the syntaxes, many of the functions will be of the C and C++ which can be used in Java. So which are needed by the execution engine. So all the native method libraries, which is a collection of many library functions from C and C++, which can be used in Java. So what is the next thing? That the Java software compilation and execution process. So how the compilation and execution process will be completed in our this part, that is, in order to write and execute a software program in Java, written in Java, you need the following. See, not only in Java, you can see in the C and C++ also. So first thing that we have to write in a program, that is, we require editor to type your program into a notepad, could be used for this. We required a compiler to convert your high-level language program into native machine code, that we require compiler. We require the third thing, that is linker, to combine different program files reference in your main program together. The next thing, we require that loader. So to load the files from your secondary storage device, like hard disk, flash drive, CD into RAM for execution, the loading is automatically done when you execute your code. So loader is also required. So that will be a secondary device, and that will be again very important, plays important role while loading and execution of our software program, maybe in C or C++ or any other programming language. Next is the execution of that software code or source code, which is written in any language. The actual execution of the code, which is handled by your operating system and the processor. So exactly how your program will get executed, written in code, maybe in C, C++, or Java, or any other languages. So that will be handled by all these different components. That is, we require editor to write this program. We require compiler to compile, and in machine code, we require to link this program into reference to all different things. the loader which will require the hard disk or flash drive, or any automatically you can do the execution of your code, and execution will be done with our program. So that is the particularly procedure about the software. Any source code will be get compiled and executed. But how the Java code compilation and execution is done in Java virtual machine? So let us look about this process of Java. We know that just in last slide we have seen about the how any software code or source code will be get compiled and executed. So let us look at how the procedure will be done in Java. In just at the right hand side, we have one figure which will show the number of Java programs as well as number of classes. In our main, we have two methods. We have two methods, that is F1 and F2. So see here at the right hand side, in the main function there are two methods, that is F1 method and F2 method. So this is the Java program named as a1.java. The main method is stored in the file a1.java. So all these two is having F1 and F2, and those all are stored in a1.java. The main method is stored in a file as a2.java. So what is F1 is stored here in a2.java. So particularly see here a1 Java contains in program, and one is a method which is stored and get called from a1.java program, but it is written in another particular thing, another place. F2 is also stored in a file as a a3.java. See here a3.java is written, that contains F2 file, F2 function. So what is this? The compiler will compile the three files and produces three corresponding .class files which consist of bytecode. Now there are three class files. At the right hand side of this figure, we can see here a1.class, a2.class, and a3.class. So how it is done? By using compiler. So compiler will compile these three files, that is a1.java, a2.java, a3.java, and corresponding .class files are created. This will consist of bytecode. Now this particularly .class files consist of bytecodes. Unlike C, there is no linking is done with the Java. See here at the upper side of this figure, what is written? No linking is done. No linking is done. And the .class file contain the bytecode. So at the right hand side, those .class file is containing a bytecode of corresponding A1, A2, and A3.java files. The Java virtual machine, it resides on the RAM. Now this particularly Java virtual machine is actually in the RAM. During execution, using the class loader, the class files are brought on the RAM. Which files? See here, a1.class, a2.class, and a3.class files will be again moved to the class loaders. So when execution is done, during execution, the class loader, the class files are brought into RAM. The bytecode is verified for any security breaches. The bytecode is verified. So when the compiler will be created, the compiler created this A1, A2 and A3 class files. So those class files contains bytecode and it will be verified for any security breaches. So there is a more security in Java as compared to other languages like C and C++. Okay, so this is a code compilation and execution in Java virtual machine. Let us look to the next. This is also the Java code compilation and execution in Java virtual machines. You can see here how it will be done. The next thing, the execution engine will convert the bytecode into native machine code. See here, JIT converts bytecode into machine code. JIT, what is the long form of JIT? That is just in time compiler. Just in time compiler. This is written here. This is just in time compiling. So it is one of the main reason why Java is comparatively slow. See here, sometimes we can say that Java is some sort of a little bit slow working of Java will be done, but it is due to just-in-time compiler. So what is that? JIT or just-in-time compiler is the part of our Java virtual machine. So what is this JIT? It is a part of Java virtual machine. So JIT is a compiler which will compile the bytecode into native code. So this will interpret the part of the bytecode that has similar functionality at the same time. So here you can see here A1.class, A2.class and A3.class, which are actually the classes after compilation. These classes are created because we have provided .java files. When we write any Java program, the extension of our Java program will be .java, .java. That will get converted to the .class files. So that will be stored in the RAM. See here, the RAM side is at the outer side, and the inner side, at the internal side, there is a Java virtual machine. Now this A1, A2 and A3 .class files will be given to the JVM, Java virtual machine. So the class loader again takes these files and convert it to the bytecode. So who does this? That JIT converter converts this into bytecode, and that will be get verified all the code and whether it is written correctly or not. Later on, the JIT code generator will generate particularly the outcome of our program, and execution engine will execute that particularly our Java program. So that is the happening of our compilation and execution of any Java program in our Java compiler as well as interpreter. We know that we have already seen about that Java uses compiler as well as interpreter. Java is using compilation process, also interpretation process. In the first level, Java compiles our source code, that is .java file, into the .class files. In the last slide, we have seen this. Later on, these .class files are actually in the RAM and that will be again get translated into JVM, Java virtual machine. So Java virtual machine is containing the just-in-time compiler. Now, just-in-time compiler is also particularly a compiler which is used by Java. So, but it is a part of Java virtual machine. JIT, that is just-in-time compiler, is a part of our Java virtual machine. what it does, it interprets part of bytecode. Now bytecode was written in a1.class file. So that is similar functionality at the same time. So just-in-time compiler will interpret the bytecode and its functionality at the execution engine. Okay, so that is the Java code compilation and execution. Thank you very much, all of you. Very importantly, you have attended this lecture, and many of the students are there. I think there are 45 students. I don't know how many students are actually just there are 45 students, but in our this 43 students are there, myself in 2 participants. Don't go away from this now. I think all of you have learned about this all things. I think we have to stop here, but before stopping our lecture, we have to get some points to be considered here. That Java language, we have to conduct one test for Java as well as C#. So for the both papers, we have to conduct the test. In our next session, or otherwise I will give you Google form for conducting any test. You can just solve that test and submit that test. That will be better to you. So I think in our maybe in the next meaning of time, I will give you the test for Java as well as C#. Okay, getting this all of you. Okay, thank you very much, all of you. Make your audio and video on again now. Let us hope that you all are very healthy and safely. All of you, there are 42 students now. Make your video on. Make your video you. Start your video. Ankita More has started. Everybody going to start videos. Much. Vaishnavi, start your videos. Ankita Shinde, Neelam More, Dhanasri Patel, Mansi Patel, Mrunali Patel, Kaleni, start your. Are you all okay?
Yes, sir.
Are you all okay? Yes?
Yes, sir.
Only one
Yes,
is
sir.
telling me that I'm okay. Everybody is
Yes, sir.
okay. Everybody is healthy in this pandemic
Yes, sir.
situation, in the COVID-19 situation. Everybody is okay. Maybe
Yes, sir.
our college will get started after Diwali vacations. I don't know, but let us start there are some examinations which are going to held in the next week, as well as many backlog papers are nowadays. Many students are attempting the backlog papers. I think many of you have started. Good one, Pranoti. Everything is get recorded in our computer. Don't worry. Your all situations, all videos and audios will be get recorded in our computer. So that I have told you to start your videos. Mrinali Patil, where is your face? Mrinali. Poonam Patil. Akanksha More, Bolte Pratibha, you have not started your videos. Pratibha Moite, Afrin Malani, Patil Neelam, Pratiksha Patil, Poonam Patil, Priyanka Pawar, you have not started your videos. This all will be stored in our laptop. Okay, Ankita Shinde, Nikita Todkar, Pratiksha Patil, start your videos. Kalani Nikam Pranam.